Right, this is issue number 6 for the Kaiju Engine. We're going to be creating a transform as part of our matrix package, and we're putting it in here because we want to have um, the best performance with the other math functions, and also access to private functions for the mathematics stuff. So this is going to be transform.go. This is a standard transform that denotes a position, rotation, and scale within three-dimensional space. And you can apply this to any entity, and transforms can have parent transforms, and those should appropriately do the multiplication needed to transform them based off of their parent or world space, depending on whether there is a parent or not. So we're going to start off by importing the math library, and we're going to create our type transform structure. And this can have a quaternion, but we're not going to do that right now. I'll probably come back for that. So for now, we're going to have a matrix that is internal to it, that is private, a parent that is internal to it, that is also private, then a position, rotation, and scale, which is going to be a vector 3. Those are public. We don't really want to set these though. This is just public accessibility. So I may come back and make those privates. So is dirty is going to be a bool. And I like to have this extra one is live, which if it is live, that means that it should update its matrix every frame or every update. Whereas otherwise, it's only going to update when it knows that it's dirty. So before we get too far in, I might actually go ahead and make these private position, rotation, and scale, and make the getter functions for these instead. That way we're not setting them directly. Setting them directly obviously isn't going to set the as dirty, and so things will get all weird otherwise. So we're going to say new transform, and we'll do it my way. Return a, we're not going to need a pointer. We're going to allow it to be on the stack if it needs to be. Map for identity. Position is going to be vec3 0. Rotation scale is going to be 1. Is dirty is going to start off as true, and live is false. We don't need to set that because Go will set that for us. Now, before we get to the parent function, because that's what I have next to my notes, I'm actually going to have some helper functions. The ability to get the right, which is going to return t.matrix.right.normal. And then we're going to get the up, which is going to return the matrix up normal, forward, forward normal. So we want to be able to arbitrarily set this this matrix dirty. T transform set dirty, which is just going to do set dirty. We need a reset dirty function so we can externally reset this dirty, because we may want to multiply the transform without altering the matrix. Sorry, we may want to multiply the matrix without altering it, and we don't want to reset the dirty when we get the matrix in that case. So it's just some flexibility that we have. So I'm going to have the is dirty, and I'm also going to have func t transform reset dirty. And it's not just going to do is dirty is false. We're going to say if t dot is dirty, then we're going to do t dot update matrix, and then we're going to say dirty is false. So we need to update the matrix if we're going to reset the dirty. You just have to make sure it's correct. So now we can do the set position, t transform set position, and we want to make sure that if not t dot position equals the position, this is a lowercase p, then we're going to do we're going to set it and set dirty. And similarly, we're going to do the same thing for rotation and scale. So that should automatically populate those. Pretty straightforward. Now we want to be able to start the live that I was talking about. Form start live and stop live. Okay, so now we want to we want to update the matrix. T transform update matrix, and this is going to do if t dot is dirty or t dot is live. Then we're going to say t dot matrix dot reset, t dot matrix dot scale by the scale, rotate by the rotation, translate by the translation. And then we want to be able to get the matrix. I don't know how it knew I was going to do that. Probably because it knows some of the other stuff I've done before. So func t transform, we want to be able to get to the world matrix, and we want to pass in a mat4 that we're going to apply this world matrix to. So m is equal to t dot matrix, m dot reset, m dot scale. We're going to rotate, translate, and then we're going to say b pos is equal to the base dot position. Yeah, that's right. And then d pos is equal to t dot position add b pos. Base dot multiply assign the m base dot set translation to d pos if t dot parent is not equal to nil. So if we have a parent, we can say t parent world matrix to the base. So I'm missing an equals there. Okay, now we're going to have a function for copying this matrix. T transform copy other transform. We want to set the position to the other, rotation to the other, the scale to the other. T dot matrix equals other dot matrix, and then we want to set this t dot is dirty equal to the other is dirty, so we don't have to recalculate it if we don't need to. And now we want to get the func t transform world transform. And here we're going to return 3 vec3s for position, rotation, and scale. So pos, rot, scale equals vec3, vec3, vec3. Sorry, this one's vec3, 1. I guess we can make this explicit. Okay, p is equal to the reference of t, and then for p is not nil, pp rss is equal to p dot position, rotation and scale, pos dot add assign, pp rot dot add assign, and then scale dot multiply assign, ss p equals the parent, and then we're going to return position, rotation, scale. This will give us the world position, rotation, and scale. And now we want to be able to get just the position, just the rotation, or just the scale. So we don't have to do all that work if we don't need to. So world position. And this is going to be pos is equal to 0. And let's see if it guessed right. So get the t, position, add assign. Yeah, that's pretty straightforward. The rotation is going to be the same. P, R, rotation. Yep. Glad that it kept my things here, but we can just call this R, I think. No, let's keep it RR so it's the same. And then we're going to do scale. That should be multiply assign. And now we can set the world position, and this is just so that if we have a transform form that has a parent, we can, instead of setting its position local to the parent, which is what set position does, we can set the position of it in the world. So set world position vec3 p is equal to t dot parent. For p is not equal to nil, we're going to pp is equal to parent position, position subtract assign, and then p is the parent. And then we can do p dot set position because we want to set the dirty to true on that one. And we can set the world rotation, which is likewise, and then we can set the world scale. Cool. And use divide assign, which is correct. So now the only thing we're missing here is the set parent function. So func t transform set parent transform, and we're going to say pos rot scale is equal to t dot world transform, t dot parent is equal to parent. We want to get its current world transform, because when we reparent or move it to another parent, we want it to stay the same size. So imagine that you have a player and you parent it to some planet. If you unparent it from the planet, it shouldn't just the player shouldn't get bigger or smaller. It should stay the same exact size and be in the same exact position it was when you detached it from being attached to the planet. So that's essentially what we're going to be doing here. If t dot parent is not equal to nil, prs is equal to t dot parent dot world transform. So this is where we're saying if it currently, if the parent we passed in is an actual parent and it's not just blank, we're going to go through and do this. So pos subtract assign p, rotation subtract assign. If the absolute value of s dot x is less than or equal to math dot smallest float 32, I don't know why it did that, or smallest float 64, we can do scale dot set x to 0. And else we're going to do scale dot set x to the scale dot x divided by scale x. Okay. And let's see if it can do the rest of them for me. Set y to 0, same thing, yep. And then z, set z to 0, 0. Okay. Cool, so that takes care of those. And now outside of the if statement, we can say t dot set position, rotation, scale. Okay, so that pretty much wraps it up for what we're doing with the transform. We have all of our functions prepared for parenting this transform, positioning it in 3D space. If there's any bugs or mistakes, those will come up when we see them, and we can come back and repair them then. But this is the general concept. Here's a couple of good catches. We need these to be pointers. So thank goodness for that. Catch, set position. This one needs to be a pointer as well. We're just assigning, it's not catching this one. So we need to come through here and set these pointers. Set rotation, set to scale. Start live. Here, let's go to the top just in case. Transform, set parent. These don't need it. Set dirty, reset. Is dirty, doesn't need it. Set. Start live, stop live. Update matrix. Let's see here. If the T is dirty, T is live, T.matrix reset. Yeah, we're going to have to make that one a pointer. And this one just gets the matrix. This one, T.scale. This one doesn't. Maybe it's because of this parenting stuff. So leave that there. Copy of this one. We technically don't need this to do that, but we'll leave it. World transform, that doesn't change anything. That doesn't change anything. World scale set, this one does, and this one does. Okay, cool. So there we go. That's our transform, and that should be it for this PR.